Hello all. Today we are beginning chapter 11 on probability. Our first lesson we are going to cover is 11.1, the fundamental counting principle. So you guys will be able to use this fundamental counting principle by the end of today's notes. So, the first thing we want to look at is the idea of the fundamental counting principle. So, we have event M can occur in M ways. This is just how we set up an equation. We also have event N can occur in N ways. So, in the event that both M and N occur, this is in M times N ways. So the fundamental counting principle is basically just the idea of this multiplication here. So, a women's department store sells 3 different types of shirts and 2 different types of pants. How many different outfits are there? Here's how it works, or here's why it works. On a small problem like this, we can actually just draw out all of the possibilities. We have 3 shirts. So we have shirt 1, we have shirt 2, and we have shirt 3. Now, you can follow that up with pant 1, pant 2 with the first shirt, or pant 1, pant 2 with the second shirt, or pant 1 and pant 2 with the third shirt. So if you notice, there are actually 6 different outfits. You can just count that up by the end over here. So we have 1, 2, 3, 4, 5, 6. So there are 6 outfits. So the shorthand here would have just been 2 times 3 equals 6. So we can do that on the next one. You're ordering lunch at the restaurant below, and you eat a sandwich, a side, and a drink. How many different ways could you choose lunch? Well, we have 5 different sandwich choices. We have 4 different side choices. And we have 8 different drink choices. So because we have 5 and 4 and 8, you just simply take 5 times 4 times 8. When you multiply those, you end up getting 160 different meal choices. Okay, so that is way too many to write out. We would not want to have done this like sort of tree diagram there. It's much easier to just use that fundamental counting principle. So we do the same thing on the next one. How many different outfits can be made from this closet below? Outfits consist of 1 shirt, 1 bottom, and 1 pair of shoes. So we first need to figure out how many shirts do we have. 1, 2, 3, 4. So we have 4 shirts. How many bottoms do we have? 1, 2, 3, 4, 5 bottoms, or pants, I suppose you could say. And then we have 1, ooh, that color's too close. We'll do green. 1, 2, 3, 4 pairs of shoes. So using the fundamental counting principle, you simply multiply 4 times 5 times 4. That equals 80 outfits. Once again, way too much to write out. Much easier to just use the fundamental counting principle. Okay. Go again. Each event can occur in the given number of ways. Find the number of ways all the events can occur. Well, if event 1 occurs 5 ways and event 2 can occur 4 ways, we could write out that tree diagram, or we can just use the fundamental counting principle and get a total of 20 ways this could occur. Now these next two I think are pretty fun. How many different license plates could be made given the format below? This is a little trickier because we have to think about some things. So this format below, we have three numbers and 3 letters. So if we allow for repetition like we have here, 999, AAA, we need to ask ourselves, how many numbers are there between 0 and 9? Because these are all of our single-digit number choices. Now, a lot of you, I would guess, would probably say, okay, well, between 0 and 9, there's 9 numbers. Actually, if you count them up, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if we could choose any of those numbers 3 times in a row, you could say 10 times 10 times 10. Because we could repeat 9 3 times, and you have the same amount of numbers still available. Letters now, we're going to follow this up with letters. We need letters A to Z. Hopefully you guys know that there's 26 letters in the alphabet. So if we take 26 times 26 times 26, because we can repeat those letters, and there are actually a lot of options. Because of our allowing for repetition, we have 17,576,000 different options just for this sort of plate. If we don't want repetition though, say once you use a 9, you can't use it again, that will change it a little bit. We do have the same option for 3 numbers, 3 letters. So number between 0 and 9, and number of letters between A and Z. Okay, now the difference here is, originally up here, we'll look back up here, we had 10 number choices. Now, if we don't want repetition, say we used 4 as our first number, how many numbers do we actually have left now? So we start with 10 options, but then as we use one, we actually only have 9 options. And then as we use another, say 2 was used, we only have 8 options. So you have to keep taking one away. Same thing with your letters. You start with 26 choices, but as you use one, if we can't repeat it, you have to take an option away. And then if you have used 2, you have to take it away again. So you end up getting 10 times 9 times 8 times 26 times 25 times 24. And this gives you significantly less options. We actually get 11,232,000 options for this specification. So without repetition, you can't use the letter A twice. You actually have less tries or less choices. So that is the fundamental counting principle. It's just really a lot of multiplication. Alrighty, have a great day.